Let us do miscellaneous exercise of chapter 2. Question number 1. The relation f is defined by f of x is equal to x square if 0 less than or equal to x less than or equal to 3, and 3x if 3 less than or equal to x less than or equal to 10. So the domain of this function f of x is 0 to 10, including 0 and 10. If you see the interval 0 less than or equal to x less than 3, f of x is defined as x square, which is a polynomial. And in the interval 3 less than x less than or equal to 10, f of x is again a polynomial, which is 3x. We know that polynomials are functions. Now the problem is at x is equal to 3, because we have two different definitions. So let us check at x is equal to 3. From the first definition, it is x square, which is 3 square. 3 square is 9. Using the second definition, it is 3x. X is 3, so 3 3s are 9. Both are giving you the same value. Therefore, f of x has unique image for all x in the interval 0 to 10, including 0 and 10. Therefore, f of x is a function. Now the second one, the definition of g of x is given as x square 0 less than or equal to x less than or equal to 2, and 3x for 2 less than or equal to x less than or equal to 10. Similarly, if you consider 0 less than or equal to x less than 2, g of x definition is x square, which is a polynomial, quadratic polynomial. And next, in this interval 2 less than x less than or equal to 10, g of x is defined as 3x, which is again a polynomial. So polynomials are functions. These are functions in these intervals. Now let us check at x is equal to 2. At x is equal to 2, we have two different definitions. So let us use the first definition. G of x is x square. So 2 square. 2 square is 4. And I am using the second definition of g of x, that is 3x. 3 into 2, which gives you 6. So the element 2 has two images. Therefore, it is not a function. Element 2 has two images, 4 and 6. Therefore, g of x is not a function. Question number 2. If f of x is equal to x square, find f of 1.1 minus f of 1 divided by 1.1 minus 1. This is an easy question, just we have to substitute the values which are given. So f of 1.1 will be 1.1 the whole square minus 1 square divided by 1.1 minus 1. 1.1 square is 1.21 and 1.1 minus 1 is 0.1. This is 0.21 divided by 0.1. Let us remove the decimal point from the denominator. I am multiplying both numerator and denominator by 10. So it gives you 2.1 divided by 1. The answer is 2.1. Third question. Find the domain of the function f of x is equal to x square plus 2x plus 1 divided by x square minus 8x plus 12. I have told you, if you have a function in the denominator should not become 0. The denominator is x square minus 8x plus 12. It should not be 0. Let us factorize this. X minus 6 into x minus 2 should not become 0. That means x should not take the values 2 or 6. Other than 2 or 6, x can take any value. Therefore, the domain of this function is, it can take any real value. X can take any real value other than 2 or 6. Question number 4. Find the domain and range of the real function defined by f of x is equal to root of x minus 1. Again, we know that if you have a function under square root, the function which is under the square root should be greater than or equal to 0. Since it is in the numerator, you can include 0 also. That means x should be greater than or equal to 1. So x can take any real value which is more than 1 and equal to 1 also, it is possible. Let us write the domain. So domain of this function is 1 is included, 1 to infinity. Let us find the range. If x is 1, f of x becomes 1 minus 1, 0. As you increase the value of x, x minus 1 keeps on increasing. So f of x keeps on increasing. Therefore, range will be 0 is included to infinity. As you increase the value of x, f of x keeps on increasing, so it goes up to infinity. Therefore, the range is 0 to infinity, including 0. Question number 5. Find the domain and range of the real function defined by f of x is equal to absolute value of x minus 1. Absolute value function, we don't have any problem. X can take any real value. So the domain of this function is R. Now range. We know that absolute value function takes positive values and it can be 0 also. If x is 1, f of x becomes 0. It can take the value 0 and all other positive real values also it can take. Therefore, it becomes 0 to infinity. Or you may write it as non-negative real numbers. Question number 6. Let f be x comma x square divided by 1 plus x square, where x belongs to R. Be a function from R into R. Determine the range of f. So domain is given here. X belonging to R is the domain. F of x is equal to x square divided by 1 plus x square. That is, x is related to x square by 1 plus x square. This is our f of x. Now, if you see this function of f of x, I can say that it is positive because you have only x square terms. So we know that f of x is positive. And look at the denominator, 1 plus x square. Numerator is x square, denominator is 1 plus x square. So 1 more than the numerator. So I can say that f of x, which is x square by 1 plus x square, will take values which are less than 1. because the denominator is a bigger number than the numerator, so it is less than 1 and it has to be positive. And if x is 0, f of x will take the value 0. Therefore, range is equal to, it can take the value 0 and it can take all positive values, real values, but less than 1. Therefore, the range is closed at 0, open at 1. Question number 7. F and G both are from R to R. Be defined respectively by f of x is equal to x plus 1 and g of x is equal to 2x minus 3. Find f plus g. F plus g of x is f of x plus g of x. We have to add these expressions and write. So it becomes 3x minus 2. And then let us find f minus g of x, which is f of x minus g of x. F of x is x plus 1 minus of x, g of x is 2x minus 3. Distribute the negative sign. So x minus 2x is minus x. 1 plus 3 it becomes, which is 4. Let us find f by g. F divided by g of x is f of x divided by g of x, which is x plus 1 divided by 2x minus 3. And we have a condition here, 2x minus 3 should not become 0. That is, x should not be equal to 3 by 2. Question number 8. Let f be 1, 1, 2, 3, 0, minus 1 and minus 1, minus 3. F is given in rooster form here. It has 4 elements. Be a function from z to z defined by f of x is equal to ax plus b. So ax plus b is a linear function for some integers a and b. Determine a and b. We have to find the values of a and b. These are the set of all first elements, set of all second elements I am writing. 1's image is 1, 2's image is 3, 0's image is minus 1, minus 1's image is minus 3. This is from z to z. We have other elements also here. These are the values of x and these are the values of f of x. So if x is 1, f of x is also 1, the first one. If x is 1, f of x is 1. Let us substitute. So f of x is 1, x is also 1, 1 into a plus b. We got an equation in a and b. Let us get one more equation. We have two unknown quantities a and b, so we need two equations to solve. The second equation, let me use 0 and minus 1. You can use any element, but 0 will be easier. Directly we will get the answer for b. Now let us substitute x as 0 and f of x as minus 1 in this equation. F of x is minus 1, x is 0, b. So we got the answer for b. Now substitute this value in this equation. So a will be 1 minus b, 1 minus of minus 1 plus 1, Therefore, A value is 2. These are the values of A and B. Question 9. Let R be a relation from n to n defined by R is equal to set of all A comma B such that A, B are natural numbers and A is equal to B square. This is the definition of R given in set builder form. Are the following true? The first one, A comma A belongs to R for all. This is the symbol used for all A belonging to N. So if it is false, we can give a counter example. Let me take 2 comma 2. It doesn't belong to R because this condition is not satisfied. 2 square should be equal to 2. They are not equal. Therefore, it doesn't belong to R. So one counter example will be enough to show that the statement is false. Therefore, this statement is false. Now the second one. A comma B belongs to R implies B comma A belongs to R. Let me use an example. 4 comma 2. It belongs to R. The reason is 4 is equal to 2 square. The condition A is equal to B square is satisfied. But let us check for 2 comma 4. You have to interchange and check. 4 square should be equal to 2. No, they are not the same. Therefore, it doesn't belong to R. Therefore, the given statement AB belongs to R implies BA belonging to R is false. Now the third statement is A comma B belongs to R, B comma C belongs to R implies A comma C belongs to R. Let us look for a counter example. Let us take 16 and 4. It belongs to R. The reason is 16 is equal to 4 square. Satisfied. Then I am taking the second element 4 comma 2. If you see these two elements B and B, common element. So that's why I am taking 4 and 4. This also belongs to R because the definition is satisfied. 4 is equal to 2 square. But check for A comma C. Our A is 16 here and C is 2. It doesn't belong to R. The reason is 16 is not equal to 2 square. Therefore, AB belonging to R and BC belonging to R implies AC belonging to R is false. Next question. Question number 10. Let A be 1, 2, 3, 4 and set B 1, 5, 9, 11, 15 and 16. And the function f is given as 1, 5, 2, 9, 3, 1, 4, 5 and 2, 11. Are the following true? The first one is f is a relation from A to B. See all the first elements 1, 2, 3, 4, 2. They belong to the first set A. Now look at all the second elements. All the second elements are from B. So I can say that this is a subset of A cross B. So F is a subset of A cross B. Therefore, F is a relation. The definition of relation is that any subset of A cross B is called a relation. Now the second one, F is a function from A to B. Now if you see the elements 2, 9 and 2, 11, this element 2 has two images 9 and 11. But the definition of a function is every element should have a unique image. But here the element 2 has two images, therefore it is not a function. The element 2 has two images 9 and 11. Therefore, F is not a function. Question number 11. Let F be the subset of Z cross Z defined by F is equal to set of all AB, A plus B, where A and B are from Z. Is F a function from Z to Z? Justify your answer. Okay, it is not a function. I am going to use a counter example. Let us take A as 0, B as 1. So here the element AB is related to A plus B. Now AB is 0 into 1, which is 0. A plus B is 0 plus 1, which is 1. Now another example I am taking. Let us take A as 0 and B as 2. So AB will be 0, but A plus B is 2. Here the same element 0 is related to 0's image is 1 and 0's image is 2 also. So 0 element has many images. Therefore, F is not a function. You can use 0 or you may give this example also. Let us take A as 1, B as 2. AB here is 2, but A plus B is 3. Now the next example you may take A as minus 1, B as minus 2. AB will be same, plus 2, but A plus B is minus 3. So in this case the element 2 has two images 3 and minus 3. Therefore, F is not a function. Write the reason. The element 0 has more than one image because 0 has many images. Here also you can write the reason. 2 has two images. Question number 12. Let A is equal to 9, 10, 11, 12, 13 and F function is from A to N. Be defined by F of N is equal to the highest prime factor of N. Find the range of f. Let me show by arrow diagram. F is defined from A to N. A has the elements 9, 10, 11, 12 and 13. Here we have all natural numbers 1, 2, 3, 4, etc. The highest prime factor of 9. The highest prime factor of 9 is 3. The factors of 9 are 1, 3, 9. But 9 is not a prime number. So the highest prime factor is 3. 9's image is 3. Then for 10, the factors for 10 are 1, 2, 5 and 10. The highest prime factor is 5. 10's image is 5. Now 11, the factors of 11 are 1 and 11. So the highest prime factor is 11. For 12, the factors for 12 are 1, 2, 3, 4, 6 and 12. So the highest prime factor is 3. For 12, the image is 3. Then for 13, the factors of 13 are 1 and 13 is the highest prime factor. Now we have to find the range of f. Range is the set of images 3, 5, 11 and 13. Let us do example 18. Let R be the set of real numbers. Define the real function f from R to R by f of x is equal to x plus 10 and sketch the graph of this function. I am drawing the table for this function. It's a linear function. It represents a straight line, we know. If x is 0, y is 10. If x is 1, it is 11. If it is minus 3, let us take. It is 7. And if it is minus 10, the answer is 0. Let's draw the graph of this function. Let us plot these points. X-axis, y-axis, 0, 10. And for 1, it is 11, or for these are negative values, minus 2, minus 4, minus 6, minus 8, minus 10. For minus 10, it is 0. For minus 3, it is 7. Let us join these points. This is the line given. This is f of x is equal to x plus 10. Sketch the graph of this function. So a rough figure will do. Now example 19. Let R be a relation from Q to Q defined by R is equal to set of all A comma B such that A, B, they belong to Q and A minus B belongs to Z. So the question is, show that A belongs to R for all A belonging to Q. So if I take A, this condition has to be satisfied. A minus A is 0, which is an integer. Therefore, I can say that A belongs to R for all A belonging to Q. Now, second subdivision, AB belongs to R. So the condition has to be satisfied. A minus B should be an integer. If A minus B is an integer, B minus A is also an integer. So I can say that BA also belongs to R. That's what we have to prove. Therefore, AB belonging to R implies BA is also in R. Now the third condition. It is given that AB belongs to R and BC also belongs to R. So the definition has to be satisfied, this definition. So A minus B belongs to Z and B minus C is also in Z. So if two integers are added, the answer is also an integer. Let us add these numbers. That is also an integer. So I get the answer A minus C belongs to Z, which implies A comma C belongs to R. Third condition is also satisfied. So AB belonging to R and BC belonging to R implies AC belongs to R. Example 20 is same as 8th question of miscellaneous exercise. So try by yourself. Now let us do example 21. Find the domain of the function f of x is equal to x square plus 3x plus 5 divided by x square minus 5x plus 4. So we had similar question in the miscellaneous exercise, question number 3. Okay, we have x term in the denominator. We know that the denominator should not become 0. So not equal to 0. Let us factorize. We get x minus 1 into x minus 4, not equal to 0. So x cannot take the values 1 or 4. Therefore, the domain of this function is x can take any real value other than 1 and 4. Example 22. It is an important question. The function f defined by f of x is equal to 1 minus x if x is less than 0, 1 when x is equal to 0, and x plus 1 when x is greater than 0. Draw the graph of f of x. So here we have linear functions for less than 0, greater than 0, and 1 is a constant function. Let us take few negative values, few positive values. If x is 0, y is 1. If x is minus 1, 1 minus of minus 1 will become plus 1, 2. For minus 2, 1 minus of minus 2 plus 2, 3. 1 minus of minus 3, so 4. If x is 1, positive values, for x greater than 0, we have to use the expression x plus 1. So 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. Let us draw the graph of this. X-axis, y-axis. Let us plot the points. For 0 it is 1. For 1 it is 2. For 2, 3. For 3 it is 4. Similarly, for minus 1 it is 2. And for minus 2, 3. For minus 3, 4. Let us join these points. So it is absolute value of a linear function. I have told you absolute value of a linear function will take V-shape graph. So this is the graph of the given function. Actually, this given function is absolute value of x plus 1. So it can be given like this also, absolute value of x plus 1. this f of x is x plus 1 for positive values, and for negative values it is 1 minus x. So f of x is equal to 1 minus x.